Hello. Good evening, everyone. Welcome once again. Today, I'm going to cover some theoretical parts with respect to the programming language. Good evening, everyone. So, as I mentioned in last few classes, that at HDL hardware description language is totally a programming, and for that we need a desktop, we need a system, and we need a tools. Okay, to learn this programming language you should be very efficient with the syntax, right? So syntax, if you're not aware of the syntax, then you cannot make the logic. And to know the logic, to build the logic, you should know the theoretical or concept of any of anything which you want to program. For example, let's take example of digital combination and sequential. If you're not aware that how this multiplier, how the divider, how the 2s complement is working, okay, the working model, you cannot use the syntax, right? So to work on those things, it is mandatory to know the syntax and the concept. So in last few classes, if you all going through with the classes, I have started with the gate level modeling. I discuss about the primitives. I discuss how to make the or how to call the gates. Then we discuss if the gate is converted into the user identifier. Okay, that is a user library. Then how to call those libraries. Okay, then we discuss a position mapping. We discuss the pin mapping. Okay, and then we also discussed about the test benches. And in the last classes only, we discussed about the test bench and why the test bench is important. Okay, writing the code is very important, but to verify the test bench, to verify the design with the test bench is very important. Okay, because if you have 100 number of inputs and 30-40 number of outputs, you cannot write the, you cannot force the value every time. Okay, you cannot force the constant value every time. Okay, so it's better to have a test bench, write the test bench of your design, and then give the value inside the test bench, sorry, inside your textual, in the form of the textual code, and then simulate it, and then verify the design. Okay, today we are going to discuss more on more theoretical part. Like there are many elements which we call logical elements. Okay, we call it as a logical elements. We required a language element. Sorry, we required a language elements to basically I say that to make our program more efficient, more stronger. Okay, so let me take back to the. Okay, let me connect my system with. Okay. 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 So as I mentioned here in this slide, language element. Okay. So sorry for a few second gap. So basically, the language element is very important to understand. If you don't know the language elements, you basically cannot call the different syntax or how to use those language element to make the program more efficient. Okay, so let's start with this. Okay, so next slides. Okay, so before starting this, again, I need to mention two things. Uh, Whenever you are writing the code with respect to the FPGA, okay, we have to write or we have to use a different set of syntax. And whenever we are writing the code with respect to the verification, okay, we have a different set of syntax. Something are common, I can say 70-80% syntax are common, which we call as synthesizable constraints. Okay, so there are two type of constraint. One is synthesizable constraint, one is non-synthesizable constraint. Okay, so non-synthesizable constraint syntax are those which basically used for the simulation purpose, not for the generation of your netlist. Okay, similarly, now I'm going to share you some syntax, some keywords which are basically generating the hardware and which are not generating the hardware too. Okay, but for later on, if you are targeting for verification or if you are targeting for virtual simulation or if you want to see the simulation inside your console box, then there are some syntax which you have to use it. Okay, particularly I'm not using it because I'm not targeting those things for a virtual simulation. Sorry, on a console simulation. Basically, I'm targeting the whatever the design I have targeted. I want to target on my FPGA board or on the simulation. Okay, so this is my idea. But for your information, I will share something which basically help you. Okay, we will share you some those keywords or those syntax which basically helps in virtual simulation, but not actually help you in a FPGA type of simulation. Okay, so let's start. So Verilog start with a few elements that is mentioned here: blank space, tabs, and new lines. If you are aware of the C language, okay, then these are the three keywords. These are the three keywords basically used in displaying the data. Okay, I will show you with some example. You don't need to worry. So white space have no syntactical significance and can be inserted for better readability. White space is not ignored in string. So basically, white space. What is white space? Basically, while displaying the output, you need something which is clearly white or which is something is not showing you. Okay, so that is basically this white space is compromised with is comprised with all these three syntax. Okay, another important is comments. So comment is very important because it's help you for the better readability of your design. Suppose that I am designing something and I am leaving the organization, so I want my design to be tested by some other person, some other fellow. Okay, so I have made my design in so better way that I have commented each and everything like input, output, wire, what is the purpose of calling wire, what is the purpose of this particular line, everything. Okay. So we for this we have to use the syntax or we have to use the keywords called comments. So basically this is how you are using these keywords. Okay, this okay. So if you will use this particular uh, slash, okay, after the statement, then or sorry before the statement, then comment, then the statement will become totally green. Okay, so this is how you have to do the multiple line. This is for single line basically. This is for single line and this is for multiple line. Okay, nesting, like if you are using like this, okay, this and this, basically this is like this, and if you have written something and in next line if you have written something, so this is allowed. Okay, but if you are using these comments after every few lines, after every few words, and then closing it and then using again and this again, though basically this is not allowed. Okay, this is allowed like this in this format or in this format. Okay, Let's take some example. See, I'm sharing you with some example. Okay, Verilog escape sequence syntax /t. Okay, see /t. How basically you will use this /t and where? So you will use this /t. This is basically your compiler directive. Okay, used for displaying the output. So here you are using the /t means tab. Okay, then second one is /n new line. This is used for new line, and this is used for how for the backspace. Okay, this one. Okay, so this is how basically see you can see we have taken one example module test again. As I mentioned, there are the few keywords which are help to generate the hardware, and there are few keywords which are not helping you to generate the hardware. They are basically helping you with the virtual simulation. Okay, so this is a module test without any input and output. Okay, now you can see here uh, we have started the program with without input output initial begin dollar display hello /t word. Okay, and again this is the second one and this is the third one. So basically uh, I tried to explain all three how basically all three are used here. So this one is your /tab, this one is your /new line, and this one is your /backspace. So you can see the output. The first one, hello world /t means tab. Okay, so here you have basically got some space. This is the same thing tab which you are using in your system. Okay, so you will get the output but with the some space. Okay, now this is what hello /n. So this is first line, and this word will be displayed to the second line. Okay, so you can see this is example 1 and this is example 2. Hello world. So this is your first line and this is your second line. So as I mentioned that I have used the /n, okay, for the new line. So this word will display to in the new line. Okay, and this is your display A B /backspace and C. So basically this backspace is basically used and basically it replaces the previous one. So whatever the variable or whatever the input is after the /b, basically that will replace the previous one. So you can see here I have written like this a b /b c. So that means this /b backspace will replace this b, and then the c will come here. So this is your output. Okay, so again I'm it is up to you. You want to make yourself up at the FPGA level, or you want to make yourself at the simulation level in the console box. So it is up to you how you are going to use it. Okay, next. So slide next slide. So again the brief information, because these are the interview questions. Okay, generally interviewer want to check the basic understanding that whether you know the every aspect of the Verilog or not. So he or she may ask the comparison with all three /n/p and /t. Okay, so /t creates a horizontal tab spacing. Okay, /n shift output to the next, and /b remove the previous character during the display. Okay, so what is the practical use? They are mostly used in, as I mentioned, they are mostly used in test benches, debug message, simulation log. Okay, and formatted output using $display and $monitor. So $display and $monitor are generally used to basically to see the outputs. Okay, operators, very important. The I can say operators is a building block of every programming language. Without operators, you cannot think any bigger logic. Okay, so there are multiple operators available in Verilog, which I need 5-10 classes at least 5 to 6 classes or maximum 10 classes to explain. Okay, but operator is again a very important element in Verilog. If you don't know how to use the operators, you are completely uh, dead with the Verilog. You cannot write any single line with the help of operator. Okay, so you need a operator's knowledge in very depth. So please remember that if you are following me, operator is very important. Okay, if you don't know the operator, you cannot write the big codes in Verilog. Okay, so there are three types of operators basically. There are unary operators, binary operators, and ternary operators. Unary operators means you have operands and you have operators. You have two things. Okay, we will take up in detail. Don't need to worry. So this is called basically this B and C is called basically a operand. Okay, what is operand? The operators perform on some inputs. Operators perform on some inputs that is called operands, and this is your operator. Okay, so if there is a single operand, if there is a single operand, a single input, okay, then call a unary operators. And if you have a two operands, okay, then it is called a binary. And if you have a three operands, it is called a ternary. Okay, so we will we will go we will we will definitely take care of every operator in detail. Okay, with respect to the programming, not theoretical. Today's session is theoretical because we need to understand the some logic elements. Okay, some language elements. Okay, signal values. So as I mentioned in my previous classes, 2 3 classes back, that we discussed detail about there are four values in a digital or in Verilog. There's 0, 1, X and Z. 0 means low logical 0, 1 means logical 1, X or capital X means your unknown value, and Z means high impedance. Okay, so unknown means your floating state, and sorry, your impedance state is known as the floating state. Your unknown means I don't care. Okay, nothing is there, nothing is connected. Okay, so this is very important. We have already discussed. Okay, same thing we are going to use it in a Verilog also. Okay, so along with this signal values, we have some numbers that we have to represent in the form of decimal, okay, hexa, octa, and binary. And the best part is that Verilog is a case sensitive, but there are four things like your capital D, small d, capital H, small h, and capital O, small o, and capital B and small b. Okay, these are the four keywords basically is work as a both capital letter and small letter, that is in lowercase and uppercase. Okay, if somewhere you are calling D, small d or capital D along with some syntax, this is going to work. Okay, so another element in Verilog is values, signal values 0, 1, X and Z, and then representation of the numbers. Okay, let's see. See, this is the one example. Just for your reference, this is the one example. I have written one basic program. Okay, and I have not written the dollar display and all these syntax. Okay, because I don't want to do that. Okay, so just explaining you that what is basically your signal value. So module, reg, initial begin. I have taken this in under the initial. I have assigned the value A 1 tick B0, B 1 tick B1, C 1 tick BX, and D 1 tick BZ. So what is the output? Actually, the output is look like this: a is equal to 0, b is equal to 1, c is equal to x, and p is equal to z. Okay, so again, these are the just values. Okay, either you are calling AND gate and writing N1 and then out IN1 and IN2, and if this is your okay, if this is your AND gate, okay, if you are calling AND gate in programming form, or you are calling AND gate in form of the schematic, in both the term, if one value is 1, if one input is 1 and another value is x or z, then output is x only. The same thing. Okay, so in both the cases, either you are calling AND gate in this way or either calling your AND gate in a schematic. In both the cases, if you are giving one x or z, that is one input x and another input is x or z, then output is x. Okay, and if you replace this 1 with 0, then 0 x 0, one input is 0 and another input is x and z, then output is 0. Okay, I have taken basically 2 classes on this, so just request you to please go back and revise it. Okay, so this is a simple example of logic values. Okay, now very important, number format. So as I mentioned here, size, separator, radix, and number. Okay, so in number format, basically in Verilog, we basically write the number. Okay, we basically represent some number in initial. For example, I'm just, for example, like this previously. Just take a one. Just take this A1. Okay, just take example of this. So this is here. I have representing the value 0. Okay, I'm representing the value 0 in terms of one tick B0. Okay, one tick B0. Okay, so what is one, what is tick, what is B, and what is 0. This is what we are going to take in the next slide. Okay, so this is how basically in Verilog we represent the numbers. Okay, we force the value. If you want to force the value, if you want to force the value in Verilog, okay, in textual form, then we have to write in this way. Okay, if you remember our test bench, okay, if you remember our test bench, basically when we are giving the value a, actually in Verilog, I have used simple 0 or simple 1. Basically, I can give one tick b 0 also and one tick b 1 also. Okay, but I have not given because I don't want to create any confusion, because I know that this I have to taught you that what is a number system, that how we basically not number system, how we basically we represent uh, the assigning of values, the representing of the assigning of the values in Verilog. Okay, right. So you can see here size. So just take this one. Okay, size means 2. 2. This one tick means separator. B means your binary. Okay, radix. And number is what actually you want to represent. This is not a 10. This is a value 10. Okay, 2 tick B 10. That means you want to force the value 10. Okay, you want to force the value 10 basically. Okay, you want to force the value 10, but this 10 in minimum in how many numbers we can represent? 2. Okay, so 10 minimum. This is actually not a representation of this. Okay, here you can also write 1 1 also. Here you can also write 0 1 also. Here you can also write 0 0 also. Okay, so don't be get confused. This 10 is not a representation of 2. Okay, or 2 is not representing 10 here. Okay, here 10 is representing the basically number. Okay, like I want to give 3, I want to give 0, I want to give 1, I want to give 0. But what is the minimum size of that? Or I can say this 1 can be represented in minimum size is 0, 1. That is in two values. Okay, so what is the size of my 0, 1 is 2, because I can represent 0, 1 in minimum 2. ठीक है, minimum 2 values. Okay, so just take this example. This is 3 tick d6. Okay, here 6 I can represent minimum in 3 values. Okay, like in 110. Okay, we can also take 7 also. 7, that means 111. Okay, so that means this 7 from 0 to 7. Okay, okay, from 0 to 7. From 0 to 7. Okay, the minimum representation is 3 well is 3. Okay, 0000010, sorry, 010, 011, 100, 101, 110, and 111. Okay, if I will give here, for example, if I will give here 9, then what will happen? Because 9 you cannot represent in 3. 9 you can represent in 4. The size should be 4. Okay, the size should be 4. Okay, then in that case, what happened? Definitely there will be some warning or error message. Okay, so this is basically 3 tick d6 means the bit size is 3. Okay, and what is this radix? Radix is basically decimal and storage is 110. Okay, so basically you are representing 6 internal in binary terms. Okay, now 6 tick 057. 6 tick O. O means octal. Octal means 0 to 7. Octal means 0 to 7. That means just like a binary means 0 to 9. Okay, total 10 values. Decimal 0 to 9. That is total 10 values. Binary means 0 to 1. Similarly, the octal. The octal contains total 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So total 8 values it's required in octal. So octal we represent in 0 to 7. Okay. So whenever we are using the word capital O or small o, okay, the bits value should be within 7. Okay, right. So 6 tick 057. That means the size should be maximum 6. So we have to represent this 5 and 7 in maximum size 6. Okay, we have to represent this is not a 57. Okay, this is a different value 5 and 7. 5 and 7. So 5 we write in 101 in total 3 size and 111 to 6. Okay, so this is basically a representation of this. And if by mistake, if we have used an 8 here, for example, 6 tick 058, then definitely this is going to be give a warning or error, because 8 doesn't come under the octal. Okay, so whenever you are trying your programming, you have to basically uh, perform all these things. Okay, similarly 3 tick 04. Oh, octa again 4. So 4 you can represent in 3, 100. Octal, you see here 100. Okay, then 8 tick H hexadecimal, 2 is your numeric D. So what is the representation of hexa from 0 to F? Okay, 0 to 15 means 0 to F, capital F or small f. Okay, so 0 to 9 will be your decimal, and then 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Okay, so how you are going to represent it? 8. Okay, 8 tick H. H is hexadecimal 2. So basically we have to maintain the size. Okay, So D is what? A, B, C, D. D is 1010. 2 and right, and 2 we can, and we need 4 more because because we need to meet a 8. Okay, we need to meet a 8. So in that case we can write to maximum in 4 size. Okay, so 0010 and 11001. Okay, so what happen if there will be a 7? What happen if it is 7 tick H2D? No problem. D you represent in 1010 because 1010 you cannot represent in 3 values, right? So 1010 you can represent in 3, and then 2 you can represent in 010 and 1010. Total 7. Okay. Okay. What happen if we have written 3 tick H2D? Then it is easy because you cannot represent D and 2 in 3 size. Okay, you cannot represent, right? So again it will be a error, okay, or warning or whatever, right? So guys, you have to basically purchase the book. Samir Palitkar is the best book. Okay, best book is available in the market. You can. Okay, now let's take example of 16 tick HA A19. Okay, so H means hexa, 16 means total size is 16 number. Now you have to manage AA19 in 16 size. So very easy. Okay, A B C D. Sorry, D. Okay, so A means what? 1010. Okay, B means what? Sorry, capital A means what? 1010 because both A and capital A is same, representing the same. Okay, what is 1? 1 is 001, and what is 9? 1001. So basically you have divided AA19 in 4 values. Okay, what happen if it is 15? अगर ये 15 होता तो क्या होता? 15 tick HAA19. Yes, at least this one you can write in 001, and this A1010, this A1010, this A001, and this 91001, because this A and 9 you cannot represent in 3 bits. Okay, you have to represent in 4 bits. Okay, so this is what happened if it is 20. Okay, what happens if it is 20 tick HAA19? No problem. 9 means what? 1001. 1 means what? 0001. Okay, capital A means what? 1010. Small a what? 1010. And to meet the 20, to meet the size 20, okay, add 40. So either you have to do it or tool will do it. Okay, so tool will perform it. Okay, right? So this is one thing. Now 5 tick B1100X. So you are confused with this, right? X. So X is also considered one position. Okay, yeah, the whole output will be unknown only, right? Depend on the operation or logic, right? But yes, X will be considered as what? As in one element. Okay. Now 6 tick OZZ. So again here Z will be considered as what? 3 times Z, 3 times Z. Okay, so again, Z is also considered as one of the logic values. Okay, then 12 tick ZXB. See here, 12 tick ZXB. So B, you know that it is a 1010, and then 4 times you have called X and 4 times you have called Z to meet the size 12. To meet the size 12. Okay, so I request you go through this slide 2 3 times because this will help you to understand. And again, these are the interview questions. Okay, interviewer will definitely confuse you. Okay, ये क्या होगा, ऐसे कैसे होगा, ये कब होगा, ये कैसे होगा. Okay, but you have to be very thorough. It. Okay, make the notes. Okay, think at every aspect. While one thing I want to convey you, everyone, right? If you want to do engineering, okay, stop making the notes. At that time, start thinking, because if you start thinking, you will be asking the question. But what I am getting here, that everyone is believing writing the notes, 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 notes. No one is thinking, sir, ये हुआ तो क्या हुआ, ये हुआ तो क्या हुआ. Okay, so stop writing the, you stop making the notes, just think. And then, because these things are easily available online, you can forward, reverse, and you can then make the notes. Okay, so this is one thing. Next slides. So today class and tomorrow class will be more on theoretical, and then we'll move to the operators, and then operators. Then again, after the operators, then again we will back to the our this digital part. Okay. Okay. Let's see some example of Verilog elements. Okay. So this is how basically I have prepared a module in such a way that I should help you in such a way that you should analyze in terms of programming. Okay, it should not look like a theory. It should look like in terms of the programming. Okay, so this is your one of the program based on elements, Verilog elements. So initial begin. This is how A is A tick B A tick D25 C and D. So if you are assigning some values, right? If you are assigning some values, then you have to do like this. Okay. Then what is my output? The output is same. The output you can see that in terms of 8, 1, 25, 15, FF and 32. Okay. So now, very important. Okay, very important. What happen if we do not specify the size? अगर मैं size भूल गया, what is size? Okay, size. So 3 tick D5. What happen if we forget the size? If we forget the size, what happened? What is my base value? So here, if we forget the size, then the value is up to the 32 bits, or depend on the simulation, depend on the tool. Okay, depend on your system also. Okay. So what happens if we forget the size? So it is by default 32 bits. Okay. Same here, like this one. Here everything we have written. So here the output will be 32 times Z. Here hexa. What happens if we forget the size? Again 32. Okay. And what happens if we have written only the what? Only the number. Okay, we have written only the number. Okay, that is we have written only the number. That is a 3. So I don't know what is the size tick, and I don't know what is the radix. Then what is this? Then again 32 bit and 3 is what? 011. So up to 32 bit. So up to 32 bit. Okay, this is right. So what happen if the size is greater? Okay, size is greater than the value of the number. ठीक है, size is greater than the value of the number and the number in the most. Okay, what happened? For example, let's take an example of 8 tick B. What happened if this size is greater than the number? Okay, this binary is here x001 is or is already a one value. Okay, one bits group of value. So what happened to maintain this size? Okay, to maintain this size, the most significant bit is if is x 0 or z. If the most significant bit is x 0 or z, then the last value will be continue to maintain the size. Okay, so the value is, for example, this one. Okay, 8 tick bx0001. So in that case, what tool will do, or what your simulation will, what machine will do, this is the last bit, right? So it will take, it will extend to up to 3 because this is total 5. 1, 1, 1, 1, 0, 0, 0, 1. So total is now 4 and 4, 8. If this is x is z, okay, suppose that if this x is z, 8 tick b z x001, right? So size is what? 8. To maintain, this is total 5. So last bit is z. 1, 2, 3, zx001. Okay, so this is how basically your number is managed. Okay, then you have another example. 8 tick b1001. What happened? If in this case here MSB is 1, in this case if we will follow the 11111, then basically the number is changed. Okay, I want to force 9, but if we put 1111, the number is changed. So what tool will do here? It will add 40. Okay, because adding the 0 on the MSB side will not change the number. Okay, so this is one thing. Then you have another example. Just 8 tick B0110. So in that case, you need to 8, you have 4. So again 40 will add because 00110. So on the MSB side, at the MSB side, you can add 0, x and z, but not 1. You cannot extend 1. Okay, you cannot extend 1. You can extend up to the, you can extend only 0, x and z. Okay, let's take some example, few examples. What happens if no size is, see, for example here, see here, if no size is defined. Okay, just one example. If no size is defined here, this no size is defined. By default, 32 bits. Okay, so output will come like this. So meaning the size not mentioned, Verilog automatically considers minimum 32 bits value. Okay. What happened if no radix is specified? Okay, what happened if no radix is specified? Radix means your binary, decimal, octa, and hexa. So by default, you have basically no radix and no size. Nothing is specified. Okay, so your radix will be by default decimal. Okay, so you can see here if no BHOD, if nothing is specified, then by default your radix is decimal. Okay, remember this. Okay, next. What happened if size missing but base present? If size missing, see again. What happened if base is hexadecimal, size not specified, simulator extend to the minimum machine word size. Okay, so if again here means if size is missing, okay, size is missing, right? So simulator extend to the minimum machine word size. Okay, so whatever you have defined, it will take, right? So this is one case. What happened if both size and base is specified? Is a ideal. This one is your ideal. What happened if both size and base is specified? So this is ideal. The same output will come. There is nothing default here. Okay, there is nothing default here. Okay, decimal number without anything. Okay, what happened if I think that's default decimal? Some mistake I have done here. Decimal number. Okay, without anything. Okay, decimal number without anything. Okay, again. So, so decimal number. If this is your decimal number, right? For example, this is 522 also. For example, okay, right? Then again, if your size is missing, okay, then again the minimum 32 bit and default is decimal. Okay, your radix will be your decimal and default size will be 32 bit. Okay, okay. This is very important. This slide is very important. Okay, only 3 slides we have. This is very important. For any negative number, the representation of numbers in Verilog I have shown you in the positive way. And what happens if it is a negative number? Okay, that is a minus sign before the representation. Okay, negative numbers are stored in 2's complement. For example, okay, this is the right way. Basically, this is the right way to explain. Okay, this is the right way. Okay, you cannot write like this 6 take d minus 3. This is the wrong representation. Okay, this is a wrong representation. Okay, this is the right representation. Okay, so 6 tick d3. Okay, so let's take first step is your 6d3. Okay, okay, so in terms of binary, how it is going to be converted? So as you know that you can represent 3 in 6. So 3 means 0, 1, 1, and then total size is 3. Now you know that 2's complement, that minus is added. Now we have to do the 2's complement. For this, we will add 1. 0, 0, 0, 0, 1, 1 plus 1. Now this 1 and 1 will become 0. This 1 will come here. This 1 and 1 become 0. Now this 1 will come here. Okay, sorry. Then mistake. Sorry. Oh, I for okay. So minus 6 d3. Okay. So first step is that you have to convert this 3 into the binary. Total in 6 bits. Then invert it and then add. Okay. So 1 0 1 1 1 1. So let's convert this into the decimal. Okay. So this is number position number 0, position number 1, 2, 3, 4, 5. This is position number 5, 4, 3, 2, 1, 0. Okay. So minus 1 into 2 to power 5 plus 1 into 2 to power 4 plus 1 into 2 to power 3 plus 1 into 2 to power 2 plus 0 into 2 to power 1 plus 1 into 2 to power 0. So minus 5 means minus 32 plus 4 16 plus 3 8 plus 2 4 0 and 1. So 16 plus 8 24, 24 plus 8 28, 29. So minus 32 plus 29 minus 3. Okay, so this is basically representing the minus 3. This is basically representing the minus 3. Okay, so this is how basically it's work. This is also very simple. 3 tick B11. Okay, minus 3 tick B11. Okay, so this 11 means 3 actually. 11 means 3, right? You can write anything 0 1 1 0 anything. Okay, so this 11 will represent 11 invert 1's complement 0 0, then add 1, then it will become what? 0 1. Am I right? Yeah. Okay, so now what will happen here? See, I've done one thing. So now the representing if in 2's complement, this is not actually a minus 3. Okay, so what we have to do? We have to maintain the size. So it is 0 1 1, then 1 0 0, then add 1. It is like 1 0 1, then convert into decimal. This is position number 0 1 and 2. यानी कि minus 1 into 2 to power 2 plus 0 into 2 to power 1 plus 1 into plus 1 into 2 to power 0. So minus 4 plus 1. It is minus 3. Okay. Right. So I hope I'm able to explain it. Now underscore. Again, this underscore is basically used for better readability purpose. Okay. It is not used for any other purpose, right? It is generally used for better readability. So you can break the large number of values into the some group of values. Okay, so you can see here this representation you can see like in this. Okay, okay, very important. This is identifiers. So basically the identifiers I can say module name. Identifier, what is identifier? Identifier is basically a module name. So you cannot write a module name. There is something restriction in writing the module names. There are some restrictions in writing the module names or any identifier. So it should not be start with the underscore. Sorry, it's not be start with the dollar sign. Your dollar sign is basically used for the compiler directive like dollar display, dollar monitor, dollar stop, dollar finish, etc. etc. So what is valid? It start with your with alphabet. Okay, it's not start with your numeric and should not start with your special character. So this is valid. My underscore y underscore d. Okay, this is valid. But if somewhere you are calling in capital small letter and somewhere you are calling in small letter, then it's not valid. Okay, then this is not valid. So identifiers are the name assigned to different objects, allowing them to be referenced in design. And identifier is any sequence of letter A to Z, digit 0 to 9, underscore, and the special character. We can use the special character in between, but not in starting. Cannot begin with start or digit and are case sensitive. Definitely, the last example is of case sensitive. Okay, and the last slide is the escape identifier. It always start with the slash. Okay, and then last one is your keywords. So these are the keywords. Okay, these are the keywords. Some keywords are synthesizable, some keywords are not synthesizable. So let's see how much keywords we are going to explore it. Okay, so in today class we have started the language elements. We have discussed in detail with some examples. Okay, so that it should not be look like theoretical. Okay, yes, I have not written any code with respect to that because those codes are generally used for the simulation purpose. So my objective is to guide you with the synthesizable syntax so that those synthesizable syntax help you to generate the circuit or the hardware which basically we have to implement it on FPGA. Okay, so this is all from my side for today's session. I again request you. I'm not going to cover the base Verilog at very basic level. We will going to take you in very deep. Okay, like FSM modeling, task and function, etc., etc. Okay, so this is all from my side. Thank you very much. Jai Hind.